Okay, welcome class. Today we are going to start a new topic, which is going to be more on graphing, but we're going to talk about general polynomial functions, their graphs, behaviors, and things. So let's start with an example, or not example, but let's introduce the idea of the function a times x to the nth power. So we're going to talk about just the simplest polynomial functions of degree n. Okay, so again, we're going to show how the degree of the polynomial helps with graphing it and the shape of the graph. So if you look over here, so we're going to talk about this one. So just a to the x to the nth power. And so notice that again, for odd degrees, so remember from previous videos that the degree is odd means that it's going to be symmetric with respect to the origin. So odd degree, so in this case odd degree means an odd function, which means it's symmetric with respect to the origin. Okay, and that tells us that it has to be able to be rotated 180 degrees and you get the exact same graph. So it rotates and lands back on top of itself. So if you notice that f of x equal to x, that's the identity function, right? So that's symmetric with respect to x. But if we get x cubed, notice that it now is curved and it goes through the origin, but it's curved now, okay? And then at x to the 5th degree, now it becomes flatter. So here, now it's coming down, it's more narrower, right? So it's becoming more narrower from here, and it's getting closer and closer to the y-axis. And so this is becoming more and more vertical, but now it's flattening out and goes through flat here and then continues down. Okay? So there's a flattening that goes on in the middle around the origin, and the tails of the graph get more narrower. Okay? Now let's look at even functions. Now we know from our work with even functions, we know that even powers, right, mean, or even degrees in this case. So even degrees means an even function, which means it's symmetric with respect to the y-axis. And so we get graphs that look like this. So again, our basic squaring function, our parabola. And then if we go to the 4th power, now look what happens. It becomes flatter here. And the sides become more narrower. And here, even more pronounced, x to the 6th becomes almost really flat here and comes back up. So it's almost starting to look like a beaker or a glass of sorts. And so as the degrees get bigger and are even, we get this sort of behavior. It starts to flatten out in the middle by the origin, and the tails become more and more narrow. And so that's what we have here. So as with any quadratic function, so now there's also the idea that not only is the power affecting the shape of the graph, but of course a also affects the graph, as we've talked about before. So as usual, with a quadratic function, the absolute value a will determine the width of the graph. So again, if a is greater than 1, it's going to be a vertical stretch, and so the sides become more narrow. So the graph becomes narrower, right? So it gets closer and closer to the y-axis. If a is between 0 and 1, then it's shrunk or compressed in the vertical direction, which causes it to become wider. Okay? And so again, that's just a little bit of review, but we're going to use that later. And so this is the behavior that we're going to start talking about, and we're going to use this idea to help us graph more accurately other types of quadratic functions that we're going to come across, or polynomial functions. Okay. That's it. Have a great day.